Hi everybody, this is my first screencast, so wish me luck. Anyway, remember back when we were in school doing science in the classroom and we were talking chemistry, and at this point you all know a lot about chemistry. So remember we talked about chemical reactions and the reactants which go into a chemical reaction and the products, what comes out of a chemical reaction. And we also talked about how every single atom that goes into a reaction also comes out of the reaction, and we are thinking about the law of conservation of matter, or also called the law of conservation of mass, as we consider all the matter that goes in has to be equal to all the matter that comes out of a reaction. Well, scientists don't just look at the matter that goes in and comes out of chemical reactions. They also look at the energy. And so now as we switch gears and start to talk about energy, we can look at reactions in terms of energy. Two words that we want to talk about today refer to this energy going into or out of a reaction. And the two words you see on the screen here are endothermic and exothermic. Now both words have the root therm here, and I think you already know that means heat, as in thermos or thermostat or thermal underwear. But these prefixes tell us the difference between them. One of them means heat is going into the reaction, and one of these means heat is being released from the reaction. So exothermic, exo is like exit, to go out. So this means heat is going out of the reaction, and this image here shows us that. We have a fire, maybe you're standing by a fireplace or a fire pit, and you can feel the heat coming off of that burning matter here. So heat is going off to the surroundings, and this reaction is much hotter than the surroundings, so it's going to give off heat to warm up those surroundings. The other type of reaction is an endothermic reaction. And here they're using just a physical change to demonstrate that. So even in a physical change, such as melting an ice cube, we know there's no breaking of bonds, so no new chemical reaction is taking place, but yet we still have an energy change. So what's happening is energy in the form of heat, thermal energy from the surroundings are moving into the ice cube, causing the structure of those molecules to change, giving it energy. They move around more, and that solid ice turns to liquid water molecules. So that's an endothermic reaction. There's another endothermic reaction that I think is more commonly known to you, and it is shown here by this cold pack. Most first aid kits have a cold pack. If you've played sports, I'm sure you've seen them. So these cold packs contain chemicals. And notice the instructions, activate. What you have to do is mix the two chemicals. Usually there's some very minimal separator here. And once you shake it up and you mix the chemicals, you allow that chemical reaction to occur. So when that chemical reaction occurs, what happens is the heat inside the system is much lower than what's going on outside. So heat moves from the surroundings to that cold pack, absorbing heat. Heat is going into the reaction. So it's endothermic. Another example, this time of an exothermic reaction. Nope, not that. Not that. Perhaps this. Yeah, there's the one I wanted. So here's another example of something on the market that uses basic chemistry. These are hand warmers. So unlike the cold pack, rather than absorb heat, these give off heat. And these are great if you're skiing, if you're out in the cold. Just like the cold pack, they contain chemicals. And these chemicals, when mixed, will give off heat, and therefore they can warm you up if they're giving off heat to the surroundings. So, our focus is exothermic versus endothermic, and we want to make sure that we can distinguish between the two. So this is a helpful image. In an exothermic reaction, the reaction itself is hotter than everything else around it, so it's going to give off that heat to spread out that energy. In an endothermic reaction, the reaction is cooler than everything else. So what happens is energy from the surroundings rushes in to try to equalize that energy. And so we have energy going in. It feels colder. Your task is to go on IXL, and let me see, that's not the one. Let's see if I can find it. IXL, there it is. So when you go on IXL, you're going to log in using your math login information. It's all the same. Just to make sure that at the top of the screen, you go to Science, and we are going to go down to Chemical Reactions. So it's 7 for grade 7, Science, 7F4. Describe energies in chemical reactions. And you are going to read the passages, and you're going to decide what's happening in the reaction in terms of energy. Is it exothermic or endothermic? Is it warmer or colder? So these are tricky at first. Read them carefully, read them a couple of times, do your best. Let's see how we do.